Hi, in this video I want to give you an example of a ring with no unit element. So a ring without one. So this is an example of a ring without unity. So it's missing the unit element for multiplication, because it always has the additive one, because a ring by default is always in an additive group. But under multiplication, it doesn't necessarily need to have the unit element. Okay, so what is this ring? Well, it's pretty simple. It's 2z, all the multiples of 2. So it's going to be 0, plus or minus 2, plus or minus 4, etc. So this is the set of even integers, right? The set of even integers, right? This does not have a unit element, so has no unit element. It's a commutative ring. It's pretty easy to see it's a ring, right? First of all, it's a group. It's a very easy proof to show. I think I actually have a video showing that this is a group here on the channel. So yeah, it is a group. It's super easy to show. You just show closure. It's fun because you know it's even numbers. The sum of two even numbers is even, and then everything else is pretty easy, inverses and stuff. Associativity of multiplication is clear because these are integers, so it works for integers. Likewise, the distributive law holds for integers, and these are also integers, so it's really simple. I hope it's been helpful. Take care.